Hello everyone, my name is Anthony Shivkumar, and in today's video I want to talk about the NRF Sniffer tool. Now the NRF Sniffer is this small little utility which can be programmed on some of the NRF 2150 modules, and I'm using the dongle, which can help us analyze what's happening over the air by sniffing the Bluetooth protocol basically. Now, when it comes to debugging, you can debug software, you can debug, some form of hardware, by having your oscilloscope, or you can have your logic analyzer for checking the signals. And if it's software, you can have debug statements, print statements. But how do you debug the wireless protocol that's happening, over the air? How do you know whether your module is advertising its address, whether it's able to connect to an address, and whether if there's any issues with your Bluetooth mechanism? How do you know where the issue is and how can you debug? And that's where the NRF Sniffer is a small little module that's kind of like sniffing for any of these radio signals that's happening in the air. And if you see that your module that you want is, say, for example, it's advertising its address, in order for it to connect to, say, a controller, say, for example, if you have a flight controller and you're trying to connect it to a handheld controller, is that protocol being advertised? Is the connection being established? What's happening under the hood if your wireless mechanisms do not work? Now, if it works, right off the bat, fantastic. But many times when you're creating custom hardware and things don't work, it's always good to know and have the debug mechanisms in order for you to, find and troubleshoot your problems. So this inexpensive product, which is the NRF 2150, you need to program it with the NRF Sniffer code, is able to now connect to WireShock, which is this utility, and especially in networking, where this particular tool called WireShock is able to decipher packets, especially Ethernet packets, or the the OSI packets as they call it. You can use this as a plugin, where NRF gives you this plugin where you can attach it, download the plugin and connect it to the WireShock, and then it's able to, you open WireShock and then you can see all your Bluetooth packets. So in this video, let's dive through, what it takes to get this all up and running, and let's try to, debug and sniff some packets over the air. So let's get started. Now, before we get started, I just want to show you my setup. What I have over here is the NRF 2150 dongle. And here I've already programmed it with the NRF Sniffer software or firmware. And this is already programmed. There are a lot of instructions online to how to get this up and running. And I have two Nordic boards over here, where one will act as the flight controller and one would act like the joystick or the handle controller. And what I'm trying to do is trying to see whether they both can establish connection, and if the NRF 5340 or the NRF 2150, which is the sniffer, can see if the handle controller is advertising its address, and if the flight controller is advertising its address and the handle controller is able to connect with it when I turn it on. I also have my mobile phone over here with the NRF module, as you can see. And when I click on enable, for example, you can see that, and I click scan, we can go to devices, and you can download this app. I'm running on an Android. You can download this app from Nordic's website, and it has all the RSSI connections between all the different Bluetooth modules that's running in my home. There's a headset, there is a piano running, and many other stuff. But let's have a look at all the devices that we have right now. As you can see, it's able to connect to my Bluetooth. It's able to check for my piano, and there's other stuff that I don't know where it is. But as I keep searching for it, it should be able to find the Nordic UART. So this is one inexpensive way of also kind of sniffing. But if you want to go into the deeper, let me click scan. The headphones and the piano is always keeps on showing they have very strong signals. The module, which is right here, should be advertising, but it's not, which is interesting. But let's see if the NRF scanner, sniffer, is able to detect this. So I'm using my Linux computer because I kind of like Linux, and I do most of my programming on the Linux system. It's just one of my ways of working. All my Nordic infrastructure and everything that I need to do to program embedded systems, I just use a Linux-based computer. So I've got WShock installed in here. You have to and there are a few little requirements to downloading the latest WShock version. So here I have the 4.2.6, which is I believe is the latest version of WShock, if nothing is released as of a week ago or so. And then I run this in sudo mode because it needs to have access to your all the hardware interface, so that it can capture and kind of like sniff all the packets, your wireless LAN, your Ethernet, and stuff like that. So when it has sudo access, it has full ability to to capture those packets. So when you get started, let me just close this and let me restart this whole thing, just so that we can start from a clean slate. So I do a sudo wireshark. In the meanwhile, I just want to show you, as I turn this on, you can see that the Nordic UART services is also running right here. And what we'll do is, when we start to establish a connection between the mobile phone and the Nordic UART service or the handheld controller, the sniffer should be able to kind of like capture what's happening over the air. So that's the kind of like demo that we'll try to demonstrate in this small little video. Now that we have WireShark kind of like coming up, and as you can see, it's able to capture some of the Ethernet packets that's connected to the laptop's hardware, the wireless LAN, the loopback, the Bluetooth. All of these things are being captured because it has access to the hardware, and you can see it, displaying the graphs and stuff over here. Once you install the NRF Sniffer Bluetooth plugin, I'm not going to really go into the details of it. There's a lot of resources online to do that. But in a nutshell, you just need to know, where are all your folders are, where is your root folder, where is your plugin folder, and accordingly, install your, for example, plugins over here. You should be able to install your Nordic plugin in one of these folders out here. I believe the Nordic plugin would be here, the NRF utility BLE Sniffer shared module, and you can see that it's connected to this is the location in where I have installed it in some shape or form. So yeah, that's really it. You download it from the internet, you put in the right folder based on where you've installed your WireShark and your home repository and stuff like that, and it's able to connect. And once you do that, you can go to capture, click refresh interface, and this is just most likely it's kind of like refreshing WireShark's ability to kind of like attach itself to one of these hardware modules, and then you can see the NRF Sniffer for Bluetooth that is connected. And that's the reason being is because I have actually connected already the NRF 2150. I've already downloaded the firmware, installed it in here into the dongle. I've downloaded the plugin, installed it with WireShark, and all of this is kind of like get ready to go in some shape or form. So when I click on the NRF Sniffer, it will automatically start sniffing. And when you can see that the green LED is constantly flickering. That means it's sniffing, and it's starting to capture all the Bluetooth mechanisms that's happening over the air. And here you can see it really, all the details. The details in terms of, what is the source address, what's the broadcast address, what type of communication or information is kind of like, sending, scanning, receiving. And here you can see that, it is capturing various types of Bluetooth that's around my home. And the one that's really interesting is you'll notice that this is the highest, one of the highest, the thing that's communicating the most is minus 53 decibels address. And that's basically my headset that I'm using. So if I go over here and, just click the 54, you'll see that it's only the Plantronic, and Plantronics is the headset that I'm using, and it's constantly scanning and advertising, and it's basically connected to my laptop in some shape or form. And it's very close, and it's clearly sending a lot of signals. The one that we are interested in is the Nordic UART service. Now, when I click on the Nordic UART service, it's got the address of EF, and as you can see, it's advertising its packet. So if I just, one of them click over here, you can see that you can also decipher each of these packets in the sense that you can WShock. One of the reasons why I like using a utility that I'm kind of familiar with, because I've used this when I was working in the networking field for a while, and I used to decipher a lot of these layer 1, layer 2, especially layer 2, layer 3, layer 4 of your OSI, your Ethernet packets in some shape or form. When I was working in the hardware industry, or rather networking industry, WireShark used to be the tool, to kind of analyze all these packets. And I'm doing the same thing for a Bluetooth packet. It's just that it's gonna have a different format, a different structure, but the concept is kind of the same thing. Where in the real world or in the physical world, it's just sending in these small little hexadecimal values, but they all mean something because that's the packet header. And here you can kind of decipher whether it's sending the right information. So in this particular case, every part of this address that is being broadcasted has a meaning. So as I click on different parts of this header, I can see that this channel index 37 is referencing, to this particular hexadecimal value over here. What is this? What is the RSSI signal strength? The timestamp. And as you keep going on, here you can see that this is the link layer. This is the address. The packet header, this is the address, and this is the broadcasting data in some shape or form. Now the NRF 5340, which is the handheld controller in this particular example, is now just sending an advertising. So now let's do something cool. What I'm going to do is I'm going to connect this to, before we even connect to the handheld controller, before they establish a connection, let's use my mobile phone and see, as I connect to this, how everything works. So in here, I have my mobile phone over here, and as you can see that I have connected to the Nordic. It's constantly scanning and it's constantly advertising its packets. So in some shape or form, it's basically saying, hey, you know what, I'm here. Can you, is anyone willing to, accept my connection, kind of a thing. So I'm going to use this particular mobile phone app over here, which has got the Nordic UART service, and I'm just going to click on connect, and then let's see what happens as soon as it establishes a connection. So I'm going to click connect over here. And as soon as we establish a connection, you can see that it goes for the slave master. And it's going, wait a minute. I click connect. And here it's going in a slave master while it's connected to the UART Nordic module over here. And this is just broadcasting a slave master. Now, I don't know the details of what this exactly means, but in some shape or form, there's a connection being established between the Nordic UART services and the and this Nordic app over here, and they're basically communicating some form of client-server relationship in some shape or form. So what I'm going to do is I'm going to disconnect this, and as soon as I disconnect it, you can see that the Nordic is immediately now advertising again and saying, hey, I'm here. Does anyone else want to establish a connection with me, kind of a thing. Now, of course, I'm simplifying a lot of these things, but I just want to demonstrate that if you have any bugs with your Nordic board, especially with the Bluetooth communication, the Sniffer is a very inexpensive, handy tool that you can buy for like, $20-$30, and you can do a lot in terms of, debugging these Bluetooth over the air kind of, problems. So let's connect with the handheld controller, and then we'll see something slightly different happening over here, because there's some form of encryption that also happens when we connect between two Nordic devices, between the Nordic UART services and the central service. And then once the connection is established, you will notice that there's some form of communication handshake that goes on to establish that connection, and we can see all of that when we capture it through WireShark. So let's do that. And you'll also notice that right now nothing is established, so there's no green light over here. The Nordic, whenever there's an established connection or it's kind of communicating with another device, it will show a green color over here. So as soon as I plug this in, and I'm going to turn this on, and as we turn this on, as soon as we turn this on, you can see the green light is established and the thing is established. As soon as the connection is established, it was advertising, it said it connected. And one thing that I've noticed is once this connection is established, the NRF sniffer is not able to sniff any more packets. I don't know why, but it's kind of like stopped sniffing. But in this particular case, I probably, it's also disconnected. But nevertheless, as soon as the connection is met, you will notice that it says that, I've got a slave, I'm a slave right now, or that's the controller that I'm getting. And then the prop, now because it's encrypted in some shape or form, we're not able to decipher all the packets. But we can look at one of the control messages over here. It talks about, that there's a next expected sequence number, and that's been acknowledged. If there's more data present. So this is kind of like the Bluetooth header of establishing a connection in some shape or form, where it goes from advertising, and once it establishes a connection, or if someone is interested in connecting with the Nordic UART services, the handshake messages is triggered, and once the connection is established, you kind of like everything stops working. So in a nutshell, and then when I bring it back, then it starts to sniff the other packets and stuff. So right now when I do the Nordic UART, you can see that it's kind of like stopped. But now if I turn this off, I'm just going to turn this all off. Right, all of a sudden, you can see that it's starting to advertise. So if I turn it on, the handshake is met. If I turn it off, and you can see the green light, the system will start to like again advertise. So that's pretty much how a tool like this. There's more to it. I just felt that I will just start to do an introductory video on how useful a utility tool like this is. I firmly believe that each time you invest in anything that can help you debug problems, it's always a good investment. And something of this sort, which is pretty inexpensive, can help you, debug some of the things that is happening over the air to see if, if this is advertising or it's not advertising, especially, when you can't just, when writing software all the time to like do debugs can be one way to solve it, but having a utility like, like a sniffer to see, if there is some form of advertisement that's going on or a Bluetooth message that's being communicated, that's difficult to debug just only through software, is a very handy tool and can save you, some time, especially if you're having some debug or over-the-air problems. So yeah, that's really what I wanted to demonstrate today. It's a very, a basic video, kind of like getting started on the importance or kind of like the utility of having an NRF sniffer. And many times working with Nordic devices, it's always going to be a software problem in some shape or form. And you probably could get away without using a sniffer, like just debugging your software in certain shape or form, because if you just use the default Nordic examples, the UART services and the central service, you should be able to establish this connection and see everything working. But as you start to customize the software in terms of adding, if you're designing a flight controller, you're going to add in all these sensors, you're going to have some form of threading if you're using the Zephyr RTOs, which most likely you would be using, and having all these multi-thread applications. Sometimes you'll realize like you're focusing on all the sensors and then you forgot about Bluetooth, and Bluetooth stopped working. What went wrong in some shape or form? And then you want to know whether there was something wrong with the handheld controller or whether it's not stopped advertising. Put a sniffer on, and then you can kind of like debug whether it's, oh, you know what, it's sniffing. I mean, it's advertising, but nothing is establishing a connection. There might be something, more deeper going on somewhere in the code. So it kind of give you some form of, a utility or some form of, additional insights into what's happening that you couldn't do without a sniffing tool in some shape or form. Now, there's a lot more to explore when it comes to actually sending messages between the two devices. If something goes wrong, if there's, you're sending one particular information and you want to see over the air whether it's sending that information in the way you intended to, that could be very handy, especially when you start to decipher the packets themselves, the application part of the packets. Now, when they establish a connection, the sniffer is not able to actually see the details. I believe it's encrypted in some shape or form. But that's something I would want to investigate further and probably ask Nordic, is there a way to disable the encryption just for the purpose of debugging? And as you make this into a production product, then it would be worth enabling the encryption so that you can see if the packets that you're intending to send have been received by the handheld controller, and the format is in the same way that you intended to send it. All right, that's it from me. I hope this was a useful video. If you're thinking of getting a sniffer, it's an inexpensive device. I think it would always add some value to your arsenal, especially when you're doing embedded systems and over-the-air and wireless communication. My recommendation is if anything that helps in debugging, and if it's something within your budget, it's always going to be a good value for money. knowing that the amount of time it can save you trying to, like, blindly trying to fix certain things, and if a system can tell you, that's where the problem is, it's generally always a good investment. Having said that, thank you for watching this video. Until next time, take care.